But when you're integrating something with a line inside of the function, okay, so this would be like the integral of 3x plus 7 to the 4 dx. Well, we know from our power rule that when we work backwards, we're going to have to add 1 to the exponent and divide by that number. So we're going to have a 5 here and divide by 5 and a 3x plus 7 still inside there. But a chain rule would happen if you did the derivative. Does that make sense? That if you did the derivative of this, you would have a chain rule and have to multiply by 3 in the end. So if I'm integrating and I'm working backwards, then I'm going to also have to divide by 3. New seating plan, there and there, perfect. And then, of course, plus c. So all this generalized form is saying is whenever you have a function that has a line inside of it, the inside function is a line, then you're going to also have to divide but whatever the slope of that line is. Because a chain rule would happen when you're doing the derivative, which means you'd multiply by that number. So to get rid of that number, you need to divide by that number. So integrate f of x. So if we write this, the integral of 1 over 9x minus 1 to the 8 dx. Probably takes some time first to change this into a form that we can integrate easier. And here we have a line inside of a power. So how do we do the power? Add 1 to the exponent, divide by that. And then because there's a 9 and a chain rule would happen if you did the derivative, you'd also have to divide by 9. And so we can have this form happen inside the power rule, inside a logarithm, inside e to the x, inside sine or cos. The same idea happens. So if you have 1 over ax plus b, well, a 1 over x integral would be the natural log, but a chain rule would happen, so we also divide by a. Same thing if you had e to the ax plus b. The integral of e to the x stays the same, but a chain rule would happen when you do the derivative, so now you have to divide by a. So try this one. Now, this step is not necessary, but you're allowed to bring that 15 out in front to maybe help you see that this is a 1 over x integral. And the integral of anything 1 over would be the natural log of that. But we would have had a chain rule, so we'd also divide by 3. And of course, you could simplify that to just be a 5 if you wanted to, or you could leave it like this. That'd be fine. Mm-hmm. All right. So the question was, what happens if we bring the 3x minus 5 minus 1 up front and try to do this as a power rule? Okay? First thing that happened there is you went in the wrong direction. You thought derivative when you were doing integral. So with an integral, what do we do to the exponent? We add 1. Right? And you said you subtracted 1. Okay? So if you add 1, then all of a sudden that's a 0. And then you would have to say also divide by 3. And if I simplify this, I just get 5. And if that's my function, I'm pretty sure the derivative of 5 isn't 15 over 3x minus 5. So something should feel wrong at that point. Okay? But what is really important about what just happened there is how it's so easy to mix up the derivative and the integral. Because one, you add one to the exponent, one, you subtract one from the exponent. So if all of a sudden you subtract one from the exponent, you're going to get an answer that you feel is right, which unfortunately is completely wrong. But it's so easy to make that mistake. Yes? Go back to examples, you bet. This one right here? One before that? This one that I didn't do? Yeah. Okay. I don't know why I missed that one, but good eye. Find the indefinite integral. We'll change that cube root to a 1/3. And then add 1 to the exponent. Divide by what you added by. You're going to also have to divide by the 5 because of the chain rule. We have a complex fraction here. So integrating this one, we have e, and we do have an ax plus b inside. So the derivative will start by being the same, or I mean the integral will start by being the same, and then because of a chain rule, we'd have to divide by -3. That's it. So this idea of an ax plus b, or a linear function inside of another function, can be generalized and done this way whenever that happens. So the last situation that it could be possible is looking at some of our trig functions. You could have an ax plus b align a linear function inside of sine, or a linear function inside of cos. We could have a linear function inside of tan as well. The same idea always happens. Because there would be a chain rule where you'd have to multiply by a, when integrating, we have to divide by a. Now, the other thing you have to remember is sine and cos. If I was working backwards, right, is this going to be a negative or a positive if it's sine? Working backwards, this one will be a negative. So -3 cos 6x minus 7. And a chain rule would happen where you'd multiply by 6, so we divide by 6 plus c. Try the last one. So see how you did here. If we integrated backwards, would this one be positive or negative? Negative, because the derivative of sine doesn't change signs. So we'd have negative sine 9x minus 1. Because we'd have a chain rule, we also divide by 9 plus c. So all of these examples have showed that when we have a chain rule, we have to divide if it's a simple number. And what we're going to look at next is what happens when there's a chain rule and it's not a nice function that happens next. Because then you can't just simply divide by that because that would change your derivative as well.